Hello, welcome to today's maths tutorial video where we are effectively looking at how to expand some brackets. So to make this video simulate as close as possible to what I would normally do in a lesson with students, I'm going to get you to do something. Could you have a go at trying to expand these two expressions and simplify your answer? So pause the video and have a go at that. And once you've done that, hopefully what you're going to end up getting, for instance for the first one, is to realise that 1 plus x all squared is secretly meaning 1 plus x times by 1 plus x, and if you try all the combinations of the things inside the first bracket, multiply with the things inside the second bracket, you'll get 1 plus x plus x plus x squared, which simplifies to 1 plus 2x plus x squared. And then the other pair of brackets, well, it's more than just a pair of brackets really, because it's 1 plus x all cubed, which would technically be 1 plus x times by 1 plus x times by 1 plus x, but of course we could realise that we'd already had a go at multiplying 1 plus x times by 1 plus x, so therefore we could use our answer to part A to speed things up a bit. So we've now just got to do 1 plus x times by 1 plus 2x plus x squared, which will get you 1 plus 2x plus x squared plus x plus 2x squared plus x cubed, leading to a final answer of 1 plus 3x plus 3x squared plus x cubed. Oh, wasn't that a lot of effort? And you see, that's kind of the point of what I'm trying to make today. You can multiply up brackets and you already know how to do it. The problem is, the more and more pairs of brackets you've got to do it with, it starts becoming more and more of a chore to do. So therefore, you're really going to hate me if I was then to ask you to expand the brackets with 1 plus x to the power of 6. Oh my goodness, except, you see, there's a little trick we can use to help multiply these brackets more quickly if it's just some brackets with powers. For instance, I can just look at this and I can just tell you straight away the answer would be 1 plus 6x plus 15x squared plus 20x cubed plus 15x to the power of 4 plus 6x to the power of 5 plus x to the power of 6. Just like that. Okay, admittedly some of the magic of that was destroyed by me doing this as a pre-recorded video instead of doing it live in front of a class because you can't see me, so a lot of you are probably assuming I just read all those numbers off some notes. But I didn't. What I actually did was I made use of a mathematical technique known as binomial expansion, which is a way that allows us to multiply up brackets that have got powers a lot more quickly than having to do it fully manually like we were doing above. So that is the topic for today's video, and it's something I'm going to be looking at for a couple more videos as well, because it's much better than doing it the long way. But before I show you the technique to do this, I need to show you something called Pascal's triangle, which is a triangle which starts with the number 1 at the top, and then every other row in the triangle starts and ends with the 1, sort of like this. And then to fill in the numbers inside the triangle, like for instance this one there, you take a look at the two numbers above it and add them together. So therefore the number represented by that question mark would actually be the number 2. Or for instance, if I wanted to know the number that's here, I'd add the 1 and the 2 together to get 3. So in fact, tell you what, you have a go at filling in all of these numbers in Pascal's triangle. So again, pause the video and come back to me in a few moments when you've done that. And doing that, you should get this. And I must admit, while doing that, you might have already started to get a bit suspicious, because you might have already recognised that 1, 2, 1 conveniently links up with the numbers that we got as part of expanding 1 plus x to the power of 2. These were the numbers that we got as part of expanding 1 plus x to the power of 3, and then those numbers in the bottom row are conveniently matching perfectly up with the numbers that I got when expanding 1 plus x to the power of 6. And when I say the numbers we get, I'm talking about what we call the coefficients, the numbers that are appearing in front of the x's inside this algebra. But is this a coincidence? Well, no actually. Funny enough, the process you went through to get from one row in the triangle to the next row in Pascal's triangle was simulating what you're doing when you're going from the expansion, for instance, for 1 plus x all squared to then using that to find the expansion for 1 plus x all cubed. So, therefore, that's all well and good, but what's going on really behind the scenes is that the Pascal's triangle's numbers are basically counting the numbers of combinations of things. For instance, if I want to expand out 1 plus x all cubed, there is, for instance, only one way I can get an x cubed by multiplying things in these brackets together. I can only get the x cubed by multiplying the x, by another x, by another x, and that is what gets me the x cubed. But then, if for instance I then want to find the x squared term, there is multiple ways I can do that. I could, for instance, do the x term times by the x term times by a number 1 in the other bracket, and that will get me one lot of x squared. But that's not the only way I can get an x squared, because I could instead choose to do the x times by 1 times by an x, which would get me another x squared, or the 1 times by the x to get me a third x squared, meaning in total we have 3x squared. And then you could continue that process on to see there's lots of different combinations to get just x to the power of 1, but then there's still only one way you can get the number 1 by multiplying all 3 1s in those brackets together. And so therefore, ultimately, I was just using the numbers in Pascal's triangle to know how many combinations there were of getting each particular power of x when multiplying all the brackets together. However, the problem is, if I then ask you to find 1 plus x to the power of 10, you really probably don't want to be sitting there writing out 10 rows of Pascal's triangle, and in fact, you shouldn't. You never need to do this as part of Maths A-level, because there is a quicker way of doing it, using a function on the calculator to find the numbers quickly for you. That function is called NCR, and it can be written in a number of different ways when it comes to notation, either like this, or even like this. So if you see all these different notations, they all mean the same thing. But so you understand the notation, it's worth pointing out the N and the R are just placeholders for particular numbers, which you alter depending on what it is you're specifically trying to find with the NCR function. And the way it works is the N is representing the power of the brackets that you're trying to expand. And then the R represents the power of the particular term in the expansion that you're trying to find by taking one of the things inside the original brackets you're expanding to the particular power you're trying to find. So, therefore, for instance, if I'm trying to find 1 plus x to the power of 10 really quickly, all I have to realize is the power of the brackets are 10, so therefore we know that n is equal to 10, and then actually expanding the brackets to find the constant term, basically just the number without any x's next to it, that would be 10c0. Typed into the calculator to find that. To find the coefficient of the x to the power of 1 term, that would just be 10c1, lots of x. If I want to find the x squared term, it would just be 10c2, lots of x squared. Hopefully by now you can see what I'm doing is I'm basically just changing the value of the r so it matches the power of the term I'm trying to find. So writing all this out, ultimately, still takes a bit of time to do this stuff because it's a big expansion, so there's lots of terms. But at least I'm not having to individually multiply out tons and tons of brackets in order to be able to do this. So it's still quicker. Almost there. Just a couple more left. There you go. So, the good news is, although that took a long time to write out, you can then use these things to then just work out what the full expansion is. If you plug 10c0 into the calculator using the relevant calculator function to do that, you'll just get 1. 10c1 would be 10. 10c2 would be 45. 10c3 is 120. 10c4 is 210. 10c5 is 252, 10C6 is then just 210, and that's something worth pointing out that also adds an extra layer of speed to this stuff, which is that ultimately Pascal's triangle is symmetrical by nature, so therefore when using the NCR function, after a while you don't need to start typing these numbers in anymore, because you know it's just going to repeat the numbers you've already written, but in reverse. So therefore, without even using the calculator anymore, I know the remaining terms are going to be 120 x to the power of 7 plus 45 x to the power of 8 plus 10 x to the power of 9 plus one lot of x to the power of 10. And there you go, boom, I just managed to expand 1 plus x to the power of 10 relatively quickly. It was ultimately just the effort of actually having to write out the final answer that took the most amount of time, particularly as it's worth mentioning in reality, some of you might not even bother to write this stage up here, and you just be immediately typing the relevant numbers into the calculator to get the answer you wanted. So that's me doing an example, but if you'd like to have a go at this stuff yourself, why didn't you have a quick go at something like this, 1 plus x to the power of 7? So try that one yourself now using the NCR function on your calculator. It's something that should appear on almost all scientific or graphical calculators. If you're having trouble finding it, please do either ask your teacher or consult the instruction manual for your particular calculator. But anyway, if you do try that, you will get a final answer of 1 plus 7x plus 21x squared plus 35x cubed plus 35x to the power of 4 plus 21x to the power of 5 plus 7x to the power of 6 plus x to the power of 7, where these numbers are coming from 7C0, 7C1, 7C2, 7C3, 7C4, 7C5, 7C6, 7C7. So that's ultimately the magic trick that you need in order to be able to multiply out brackets of the form 1 plus x to the power of n. NCR, super useful, much quicker than multiplying the brackets out manually. However, there is one problem with all this, which is what happens if you don't want to be multiplying out brackets of the form specifically 1 plus x to the power of something? What happens if, for instance, instead you want to be multiplying out something of this form, 2 plus 3x to the power of 5? What's going to happen then? Well, unfortunately, it's going to be a bit more complicated than what we've looked at before because there's extra layers to the process. NCR is still going to play a role, but there are more things we're going to need to do on top of that. But we've already done enough talking for today, so therefore that's something we'll leave to our next video on Maths A-level content. So hopefully see you in a future video, and hopefully you found today's video useful. Goodbye!